Let's continue our talk about sets. There are usually in math interesting operations that we can apply on sets, which are just a bunch of unique numbers. One of the very popular one is, for example, the set union. If you have these two sets and you try to union them, then it will be like the result of merging all of them together. For example, the one is common, we will have 1 and 5 and 7 and 8, and we'll have 3 and 10. Now to implement the union, to code it, there are two ways. The first way here is to use the union function. st1.union st2 is going to return for you a set of items. Observe that the set itself will not be updated. It will return for you a new set. Now Python would like to make our life easier, so they are overloading this operator, the OR operator. So when you write set1 or set2, this is how we read it. This will return this will actually implicitly will call this function and return the result for you. To understand this syntax, think of it like when you write 2 plus 3. In math, we know that 2 can be added to 3. So the Python provides us with the plus to take two objects and sum them together. In a very similar way, the OR here take two sets and compute the OR of them. In a very similar way, you can have the intersection. Either you can call the intersection method, or you can use the AND operator. So we read it like st1 and st2 and st3, which will get the intersection of all of them. I'm adding here a third set, has 5 and 6 and 1. If you try to OR all of them together, you will end up with a list. But if you try to AND all of them together, you end up with only 1 and 5. Consider here, 1 exists in st1, st2, st3, 5 exists in st1, st2, st3, but 6 exists here only, 7 here only, 3, 10 here only, and so on. As an intersection function is returning a new set, you can write set intersection set2 and then apply intersection again over the returned result. But this is a bit ridiculous. A better way is to just pass a bunch of items to be intersected together. There is also in the math sets, there is what we call the difference and symmetric difference. When we when you write a set1 minus set2, this is computing the difference between these two sets. So far we used to see the minus between two integers, two floats, and we didn't see it over the string, for example. But you can see here over sets. When you write st1 minus set2, it will return the elements that are in the first set but not in the second one. For example, consider the 1. It exists in both of them, discard. 5, both of them, discard. 7, it doesn't exist in set 2, so we return it. 8, it doesn't exist in set 2, we doesn't return it, and so on. Observe that the 3 and 10 are ignored, we don't care about them. We care about elements that are in set 1, but not in set 2. There is also what we call a symmetric difference using this operator. It is returning the elements that are either in set 1 or in set 2, but not in both of them. For example, the 7 and 8 will be considered and 3 and 10 will be considered. Probably the symmetric difference is just the union of the difference of set 1 minus set 2 and the set 2 minus set 1. There is also the is disjoint set, which is checking if no intersection or not. So st1 is disjoint with 2, this is false. But is disjoint with 4 and 6, this is true. There is also two handy methods about subsets, is subset and is superset. If you have here st1 and st2, set1 and set2, observe here set1 is subset of set2 because 1 exists here and 5 exists here. Again, for simplicity, the Python is providing you with the less than or equal. In a similar way, you can also use the less than only. The less than will check if every element in st1 and st2, but they shouldn't be equal. Think of that like the normal math. I can say 3 less than or equal 3, yes, true. But 3 less than 3, this is false. So they cannot be equal. Here, set1 is less than set2, this is true because they are set1 is subset and they aren't equal. But 1, 5 only is false. The superset is the opposite of the definition. So set2 is a superset for set1. It means it contains all of it and more. So this is what we call superset. In a similar way, the greater than is forcing it to be like, it must not be equal here. The updates, if you would like to make an update with say ORing things together, you can write st1 or equal st2, or you can use st2.update st1, and so on. This is very similar to the intersection and the difference. So if you would like, you need to use this compound assignment styles. What if you would like a set that is frozen? Observe that the set itself is mutable. We are adding and removing. If you would like to make a dictionary over set, for example, you will not be able to do that. There is also what we call a frozen set. The frozen set, once it is created, you cannot change it. This is very similar to the tuple and the string, for example. So I can if you created here set1 and printed the ID, it will be this way, this ID. Now observe this trick. If you try to write something like st1 or equal 20 and 10, st1, this will not cause an error. st1 will be changed to a new list that has a very different memory in the very different address in the memory. We learned something like that before about strings. If you have a string like ABC and then you wrote s plus equal maybe wz, the string will be changed with a new one, and the address will be changed to a new address. So this is same idea for the strings here. If you added something, it's actually changing its address. Now, as I said, having a frozen set is useful mainly for maybe for something like a dictionary. And again, you can iterate over the set using sorted items or so. Let's make a practice here so that you can see one practical example. Remember, we learned before how to filter the duplicates in a list of integers. But we did it before, and we had a condition that we need to preserve the order. And when we need to preserve the insertion order, the best thing that comes to mind is the dictionary. But if you don't care about the order, then a more direct and efficient way is just to depend on the set itself. So set here is fitting a lot the case. This is the API. Give a try before seeing my code. So to solve the code, you create here a set, and then you iterate over every list. Remember, the set is expecting immutable items. So the first thing is we will create the list to a tuple. Then if the tuple isn't in the set, we will add it to the tuple, to the set here, and we add here a result that we will return. So the result will help us to come back as a result of the set here. So overall, you iterate, convert it to tuple, add to the set if it doesn't exist, and also add to the result. Once this loop is done, then you can return the result as a filtered duplicate items. But by the way, our code here is preserving order if you observe it. Like given that I am adding the list to the result, I'm actually preserving the order. If you don't want to do that, you can, after the whole code ended, you can just return the result list of the set. This now will return also the list, but it will not preserve the order. As you see, we can preserve the order here in an easy way, so why not? That's all.